I said that what? Mirrors is for what? Reflection. While lenses has to do with what? Refraction. I will explain refraction a bit. We did refraction yesterday, as case may be, when we treated them. We had already looked at concave and convex mirror, isn't it?
It is.
How they behave when you place an object in front of them, and the properties of the image that will be formed when they finish their behaviors, isn't it? Now, you can remember that when we were introducing spherical or curved mirrors, I told you that we're still going to be doing lenses. Now listen attentively. Mirrors is for reflection. Lenses is for refraction. Noted? Alright? I said that what? Mirrors is for what? Reflection. While lenses has to do with what? Refraction. I will explain refraction a bit. We did refraction yesterday, as case may be, when we treated characteristics of a wave, isn't it?
Yes, sir.
What do you say that ripple tank is?
It's used to demonstrate all the characteristics of wave.
God bless you, Mama. Now, if we are looking at refraction, I want us to see something now. I will not talk much on refraction, but I will explain refraction so that you understand what lenses do or why they behave the way they behave. Am I communicating?
Yes,
and of
sir.
course, how they behave in opposite direction with that of what? That of mirrors. Am I communicating? Now look at the board. What is refraction?
Refraction is the change in direction of light as it passes the boundary between two medias of different densities.
Now, whenever light travels or propagates, isn't it? As soon as it's moved from a medium, or when I say whenever light travels, it means that it's already in a medium. It's traveling through a medium. Am I communicating? Now, once the density of the medium of the light changes, am I communicating? The speed, the rate at which the light move, we have to what? We have to be damped. We have to be reduced. Am I communicating?
Yes.
So if this is air, for instance, so this is air medium, all right?
Yeah.
And we know that what light travels with the speed of about what 3 times 10 power what?
8
meter per second, isn't it? So as far as this light is traveling like this through the what? Through the air, is going to moving with what? With this speed. I get to my point. This is what? Air medium. I get to my point.
Yes, sir.
Now, once this light crosses another medium, let's assume that this is water medium. Am I communicating? I like using glass, okay? Let's use what? Glass what? Medium. Excuse me. As soon as this ray, this light, hits another medium that is of higher density, am I communicating? This guy has a density less than this, isn't it? So for glass medium, glass is denser than air. True or false? So for light to pass through glass, just like we said about transmission, diffuse transmission, selective transmission, direct transmission, isn't it? You find out that for these ones, not that the glass is a barrier, but glass is an obstacle. Am I communicating?
Yeah.
I explain between the difference between barrier and obstacles to you, isn't it?
Yeah.
Now, when you say a barrier means that what? The light has to go back, and we see it under what? Reflection. So once the light rays hits the what? A barrier, it has to go back. But for obstacles, I get to my point, it can diffuse in or change direction as case may be, depending, right? So here, not that the light will stop moving or start going backward, but it's instead of moving straight like this. I'm using this to show you how the light is meant to move normally. Am I communicating?
Yes, sir.
It will do what? It will bend. It will change the what? The direction. I get to my point. So if this is known as the incident ray, then automatically this is not reflection. This is known as what? Refracted ray. So what is the refraction? It is the change in the direction of light ray, of wave, of vibration as it moves in media of different densities. As it moves in what? In media of different densities. Example, either moving from air to glass, or from glass to air, or from air to water, or from water to air. Am I communicating? Am I communicating?
Yeah.
Good. Now, two glasses, okay, can be used to represent or to show that light refracts. And these glasses are what? Are spherical. Am I communicating?
Yeah.
Are called. In that we have, and this glass is called what? Lenses or lens. The glass is called what? Lens. Am I communicating? Now this glass is of two forms since they are spherical. Okay?
Yeah.
We have number one, converging or convex what?
Lenses.
Lens. Okay. Number two,
Diverging.
Diverging or what? Concave what?
Concave.
Lens. Are you with me? Are you with me?
Yeah.
Now look at the board.
What's that?
When you what's the question?
Okay. In mirrors, convex mirrors are
Diverging mirrors.
diverging, yeah. But here it's converging.
Yes.
Uh,
Why? That is the way they are. I will show you how. Now look at the board. Now, I would love to make okay. Now, this is a convex mirror. Am I communicating? These guys are the what? Are the reflective surface. Am I communicating? The outside now, normally convex. Outside is the reflecting surface, isn't it? Now, we found out that whenever light hits on this guy here, this guy hits here, this guy hits here, this guy hits here. Are you looking at the board?
yeah.
Let me have just 5 rays, a beam, isn't it? So I have a ray, rays of light here. Once they hit here, they were coming from air, true or false?
Yeah.
Once they hit here, they will not go back because this is a glass. It's not like mirror that you coated the one side and the light is coming on that what? On that barrier. Am I communicating that will go back or something? Okay. Now here, this light will just have to bend. Okay. But due to the fact that on hitting this guy, I get to my point. Here is now looking as though the inner side is the one, is the place, is the area where the refraction will take place. Am I communicating? All these rays will begin to converge. I'm answering your question, I think.
Yeah.
If not, I would have just gone straight. All right. Now, once it hit the center, the refraction now will be happening from the inside, due to the fact that the ray have not started seeing the outer part of this glass, but on the inner part. So on the inner part, instead of bending away, it will bend what? Inwardly. Why? Simply because the inside is now looking as though it's going to be, you know, I explained it when I was teaching spherical mirrors, right? When you have hand like this, and this is your reflective surface, am I communicating? Automatically, the rays after reflection will converge. That's what happens here. So even though that the lens is looking like this, all right, is looking like this, which is convex. Am I communicating? This is concave, all right, concave. This is convex. Even though it's looking like this is the what? Reflecting surface normally, okay. But on the inside, this is where the conversion will take place. That's why you call it what? Convex or converging what? Lens. Am I communicating?
Yeah.
So all these rays after reflection will meet where? Will converge at a point. Are we together?
Yes, sir.
Are we together? Good. This is 4. So this side is glass medium. So what happens here? Air medium. Are you with me?
Yeah.
I think I should explain that of diverging
Yeah.
now as well. So here we come for diverging
Diverging.
lens. All right. Now, you know, I want to tell you something before we continue, or as I draw this. I advise you to always, whenever you want to form images, try to make the lenses to be as tiny as possible. If you make it big, you might find out that you'll be having some issues on the diagram. Okay, so this is our what do you call it? Our concave lens. When you look at this guy, the reflecting surface look what? Concave nature. Am I communicating?
Yeah.
But as soon as light begins to fall on this guy from air, all right, are you with me? What do you think? On the inside, the inside looks what? Diverging. Am I communicating? So what do you think? Once after refraction, they begin to do what? They begin to do what? Diverge, isn't it? Isn't it?
Yeah.
So these are the air medium. These are glass medium. We are looking at refraction. Is understood?
Yeah.
Is understood? Okay, so it's very important that you understand this beginning aspect of this class, because if you don't, you might find out that you get confused as we go. Are we together?
Yes, sir.
So this is called the convex or converging
Lens.
lens, isn't it?
Yeah.
This is called what? The concave or diverging
Lens.
lens, isn't it?
Yes, sir.
Is understood.
Yeah.
Can we move ahead now?
Yes, sir.
So where are we moving to? Because that was why we came here. We are moving to image formation. I can work this guy, right? We are moving to image formation. We are moving to image formation of what? Lenses. Rules. Yes, there are rules. There are rules. Now, let's look at image formation in lens. Okay. Now, first of all, we have to look at the rules. Okay.
Yeah.
But before we look at the rules, I want you to note the the quantities we find on lens. What we find on lens is not what we find in mirror.
Mirrors.
That is another reason why they behave the way they behave. Am I communicating?
Yeah.
Now, we have just 2-3 quantities that we find in lens. Number one is the what? Is the optical center. Is the what?
Optical center.
Optical center. The optical center. Now, if this guy is you, all right,
Yeah.
that you want to place yourself in front of we are starting with converging, which is convex lens.
Yeah.
Am I communicating?
Yes, sir.
You know why we are starting with converging, isn't it? Because converging, we are going to be having different properties as we move the object, okay? But for diverging, they are going to be the same. The same thing we saw when we looked at convex mirror. Am I communicating?
Yes,
the
sir.
properties will just be the same. Now look at the ball. So if this is you are standing on where? On where? On the
Principal axis.
On the principal axis. So this is you standing on the principal axis. Then I myself, I place the mirror, which is this guy. Like I said, you make it to be as tiny as possible. Okay. Are you with me? So this is our convex or converging lens, isn't it?
Yeah.
Now, at the center here, we have number one, the optical center, isn't it?
Yeah.
And number two, we have the principal axis, isn't it?
Yes.
Good. Now look at the board. You know, in mirror, we measured out 3 centimeters. All right. In lens, you measure out 2 centimeters. Am I communicating?
Yeah.
So from the optical center to this place, I'm measuring what? Measuring out 2 centimeters. Okay. And here, I will call it the what? The principal what? Focus. F1. Are you with me?
Yeah.
From F1 to here, I will have another focus, which I will call what? 2F1. This is one F1 now. 2F1, right? I'm calling it F1 because I am measuring it on this right hand side. This is the right hand side. Am I communicating? All right? Are you with me?
Yeah.
Good. Then let me move this guy backward so that good. So then from the other side as well, I will measure 2 centimeters, isn't it? 2 cm. And I will have F2. That is 1 F2. This is what? The second phase of what? Principal what? Focus. Why is it like that? Look at the board. This is a reflective surface. This is a reflective surface. Am I communicating?
Yes,
So
sir.
what we have here, we're going to have it there. Simple. Am I communicating?
Yeah.
All right. Good. So from here to here, I will measure 2 centimeters, which is what 2 for 2. Hope you're with me.
Yes, sir.
Good. Now, the first rule. The first rule. The first rule. A ray of light parallel to the principal axis after refraction. After refraction will pass through the principal focus on the other side. We pass through the principal focus of the other side. That is much more better. We pass through the principal focus of what? Of the other side. You know, when you reason it, you observe that it's almost with what we did in the other one. Just that here, in the other one, if it hits here, for instance, after reflection, it will pass through this side. Am I communicating? Yeah. But here, for converging lens, you know, once it hits here, it's not reflecting. It is refracting. It's just change direction on the other side. Do you get the point now? Do you get the point now?
Yeah.
That is rule 1. I'm wiping it off to give you rule 2. Hope you can wipe it off, right?
No.
Please be faster about it so that you won't. The class will not be too long. So you have to note these rules, because these rules will be the one that will help you in the journey of image formation of what's it called? Of a converge of lens. Am I communicating? Whether converging or diverging. It's very important, okay? Now here we have, you know, 2 foci. Here we have 2 foci. That is the nature of what? Of lens, okay? You have 2 foci on the left and 2 foci on the right. Are you with me? Rule 2. Rule 2. Rule 2.
Okay.
I'm waiting for you. You're done, right? Good.
Yeah.
Rule 2. A ray of light passing through the optical center This is it, right? Okay. A ray of light passing through the optical center moves straight without deviation. Sorry? After refraction, am I communicating? Move straight without what? Deviation. In fact, I will remove after refraction, okay? Because it's actually moving straight as far as it's on the what? Optical what? Center. Without what? Deviation. Without deviation. As you can see on the board, just straight. Am I communicating? You know why I like putting after refraction is to lay emphasis on the fact that lenses are for what? Refraction. Am I communicating? Okay. Rule 3. Hope you're drawing them. Hope you're drawing them to avoid you failing exam. Rule 3. What rule 3 will be? As usual. What is rule 3? It's separate to F2. Which one? Okay, we have this and this. Okay. In the first rule, what did you say? If this guy is parallel to the principal axis, after refraction, we move towards this side, right?
Yeah.
So what do you think? If this guy is passing through the what? The principal focus. Yeah. After refraction, we do what? After refraction, we'll pass parallel. Am I communicating? With the principal axis
On the other side.
of the other side. Don't say of the opposite side. When you say opposite side means this side. This is the incident where you are seen as a subject that is moving, isn't it? Am I communicating?
Yes, sir.
This is the what? The instance where you're seen as a subject. So when you say passes after refraction, moves parallel to the principal axis on the opposite side, automatically you're trying to tell us that it will move like this on the opposite side. Am I communicating?
Yeah.
Yeah. And when it moves like this on the opposite side, automatically, it's actually reflection, no more what? Refraction. Am I communicating? So this guy, after refraction, we do what? We move on the other side, parallel with the principal what? Axis. Is understood?
Yes,
so
sir.
this one is what? Rule what? 3. Isn't it? Now these are the only rules. The 3 rules we are going to be using for what? Forming images under what? Lens.
Master, can you call it again?
When ray of light passes through the principal focus, I get to my point.
Yeah.
Incidented on a spherical, incidented on a converging lens. Am I communicating? After refraction, moves parallel. After refraction, moves parallel with the principal axis on the other side. Moves parallel on the other side with the principal axis. However you want to put it. Just, you have it on the board, right?
Yeah.
So these 3 rules are enough for us to what? To be forming our images, isn't it? And the image is formed there. For us to form images there, we are going to be using only what? 2 out of 3. We cannot use we won't be using what? 3 of them. Am I communicating?
Yes, sir.
2 minimum, is enough. Just use 2. You can get what you want, all right? Okay, so let's go to image formation. Image what? Formation. Oh, I did not put this, guys. So here I have principal foci because I have more principal focus, all right? So where are we starting? We are looking at convex lens, isn't it? Isn't it?
Yes, sir.
So where are we placing it? Case 1. Case 1. Where do you think we are placing it? Case 1. As usual. At what? Case 1. At what? Object at what? Beyond 2F1. Isn't it? Isn't it?
Yeah.
So how do we do it? The first row can go, right?
Yeah.
This guy will move here, then refract and move toward this side. Isn't it? Isn't it?
Yes, sir.
Listen, oh. Did you hear me say appear to move? Which means our images will be real. Am I communicating? Am I communicating?
Yeah.
Am I communicating? Which means our images must be what? Real. Because I did not say appear to move there. And I'm using what? This line showing you that what? That the light ray actually refracted like actively. Am I communicating? So here I have the first one. So which other one can go? You know, our interception, our interception will form our image, isn't it? So second one is that what?
A ray of light passing through the optical center.
So if I move this guy here, you know, drawing optical center somehow looks okay. Are you with me?
Yeah.
It's only got bent here anyways, but I'm trying to capture the optical center. Okay, where is our image at the intercept, right? So our image will be here. The question is the image real?
Yeah.
Properties. Number one, the image is real because the light actually cut across the image, right? So if it's real, you're going to look what? Then I'm going to have your head coming down here and your leg being up there. Am I communicating? Am I communicating?
Yes, sir.
So what do you have on the board? What do you think? From what I'm seeing, the same size. So real and what? Inverted. Then number two, the same size. I'm looking at properties of the images from here, of images. Isn't it? So real and inverted, as you can see, isn't it? Yeah, because once the image is real, it must be inverted. That's what we said, isn't it? Then
Yes.
the same size, as you can see, you know, actually the same size with that of the what? The object size, isn't it?
Yeah.
Okay, number three. Where is it formed? It's formed at 2F2. You know, if you draw it very well, actually, it's meant to be formed at 2F2. I don't know. Is there anybody that drew with protractor, you know, with arcing and all that?
Yes, I drew. But I'm not.
Okay, we confirm because we need to know. Okay, you don't climb it, isn't it? We need to know. But the point there is that looking at it, this image is what is having the same size with that of the what, out of the object. So it's not magnified, it's not diminished. Am I communicating? Then is real and also what, inverted. Am I communicating? But I think it might form beyond 2F2. It might form beyond 2F2 because this my drawing didn't look that bad because I'm seeing it from here. From here, I actually had to meant to move it like this, like this, like this. Yeah. So it's still at that. Where did you form?
Before 2F2.
Before. No, it can't be before. What is this?
Is that now?
No, now see what you drew. Okay. Okay, I'm seeing something. Wait. Did you measure the distance very well?
Yeah.
Like the 2 cm?
I don't know.
Check. You won't form before 2F2. After 2F2. No, I mean, did you draw? Why? We are trying to confirm something. I think you're trying to confuse us for now.
Is this now?
Is he measured?
Yeah.
She's correct. I've confirmed you from my own drawing. It's formed before. So this formed that is in between image formed between what?
Between F2 and 2F2.
That is 1F2 and 2F2, right? Isn't it?
Yeah.
Very important. Okay, I'm moving straight to what? 2F1. I'm done with this. We're moving straight to what? 2F1. Raise this guy for me. I'm moving to 2F1. 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 So you are going to be coming closer. I'm going to be here, isn't it? Please, I think someone should be fast in drawing, his or her own, so that we continue confirming about not just the size, the position. Am I communicating? Yeah, because I believe we all know how to draw it. For those that don't know how to draw it, you learn and practice. If you don't practice it, you might find out that you won't learn it. It's always difficult to actually, clean this thing up. Okay, here is our optical center. Here is our F2. Here is our 2F2. Here is our F1. You see, this guy is not in line, but we're going to leave it like that. Now look at the board. So at 2F1 now, right? Isn't it? Yes. At 2F1, that is case 2. So looking at case 2 at 2F1. So this one can go, right? Then this one can go, right? Which other one can go? This one can go, right? Okay. I was thinking, okay, so let me extend my principal axis. All right. So what are the? Has anybody done forming his or her own?
Yes.
Is it real? It's not real. Is it real?
Yes.
Real and inverted. So automatically, I'm going to have this guy here. From my own, it's highly magnified. From my own, I don't know about your own. So here is what? Highly magnified. I'll confirm from people that drew. It not draw. You use the same size. You use the same size.
Yeah.
The same size. Why? It's not even the same size from here. It seems to look smaller. Let me look at it. Okay. Okay. It's from the 2F, the same size. Okay, I think she's correct. It's just from the lining. Do you understand? You know, when you stand from here, you actually see what the jargon I drew here.
It's coming from that first
From here.
one. From the first one that you drew.
From the first one. Not from the first one. I didn't even look at the first one. You see the second one? If I'm to draw it straight, this line has to move like this to start with. To move like this. Move like this. Move like this. Move like this. That's what I saw. Then on the first one, it's not even starting hitting the focus. Okay?
Yeah.
So from your book, you get the actual drawing, isn't it? Am I communicating?
Yeah.
So like I said, continue drawing so that you always give us this thing. You always give us but from your own, do you think that thing or is of the same size? Let me see that ruler.
No, I don't think it's.
Let me see the ruler. Because what I'm seeing, I think it's diminished.
One and a half. Then compared to this one, this one is like
Okay. It's of the same size. Okay. I think the distance should now be from the lining as well. Okay. So here we have what? The same size. Then number 3. Where is it from?
at F1.
At F2, at 2F2, right? It's formed.
Oh, sorry.
The image is formed where?
At 2F2.
Forms at 2F2. Are you with me?
Yes.
So where are we moving to now?
F1.
Should I go on?
Yeah.
So I can wipe the board?
No.
Okay, she actually correct. So this guy is not the same size, but I literally what diminished. The image is diminished. So I think I will be using from her. I think she is getting the measurement proper. You know, you can only confirm by yourself anyways, because someone can actually make mistake. You wouldn't know, right? So, but I think for the second time now, I'm confirming that she is doing it proper. So it's actually real inverted, then it's diminished and formed at exactly 2F2. It formed at exactly 2F2, and that is where hers were formed. So, okay, so what are we looking at? Oh, okay. Where do we place this image now? Oh, the same image. Sorry. Same size. Same size. I believe that the first one was diminished. The first was it diminished? The first one.
Yeah, it was.
It was diminished, right?
First one,
the first
yes.
one was diminished, right?
Yes.
Correct.
First one. For my book is diminished now.
Is diminished. Maybe probably I didn't say it or something like I didn't use hers to compare because she gave me the correct drawing. The measurement is what matters there, all right? So this one is having the same size. So later you can redraw that one. You'll find out that it's actually meant to be the same size if you take the proper measurement. Am I communicating?
Yes, sir.
Yeah. So where are we moving it to now?
F1.
F1 kwa? No, now in between 2F1 and F1 first. All right? You have to do in between before you do. Yeah. Can you go to F1 without being in between F1 and 2F1? Eh? Can you?
No.
Good. So where are you drawing your own now?
At
F1.
No.
In between 2F1, right?
Yeah.
And F1. Good. So let me draw mine. Of course, mine is always wrong. You know, I'm just trying to show you how to draw it, how to trace it. Isn't it? Something like this. So here, here, let me try my best. Stop that noise. Stop the noise, okay? So here is where my image, the form, and is real and also inverted.
Yeah.
So let's look at the properties for us, those that drew it in their books. So the image is it same size?
No.
What happened? Magnified.
Yeah.
Okay, so the image is magnified. Where is it from?
Beyond 2F2.
So which I'm actually correct.
Yes.
So the image from beyond 2F2. Beyond 2F2. Isn't it? So where again are we going to? F1. I can wipe it, right? So this one is between 2F1 and F1. It isn't hard.
No.
No, is it hard? No, but you're not using masses, so you can't get it. If you're not using a measuring this thing, if you are using apparatus, you can't get it. The only thing is that you know the rules, how to draw it, but using your hand is not enough, all right? So you tend to, shake your hand as you are drawing the line, or you tend not to move properly on the spot of what? Focus, or the focal you are moving with, or even optical center. That is the problem. So what else? What else? At F1. Let me go to F1.
Yeah.
I'm going to use my hand to be cleaning this board for now due to some reasons. I want to be wiping this thing again. So, at F1, let's look at what will happen. I want you to give me the correct answer. Because I'm not going to be correct. I know, because of the fact I'm not using apparatus. So which rule are we using? Rule 1. All of them. 1 and 3. So it means that this guy hit here, it will go here, isn't it? It will refract here. So what's rule 3?
Let's do rule 2.
I think I can pass here now.
Yeah. Rule 2 now.
What do you think?
Infinity.
Is he moving parallel in your own? For me, he's moving parallel from my own good. Do you see it? Like they can meet. They are not diverging and they are not converging. Like they are just parallel to it. They are just moving with the same distance. Do you see it? You see? So this is how to draw this thing, and you know what happened to the image. If you didn't get it like this, automatically you might say that, oh, that there is formed at 2f1, but this is infinity, because once it's moving parallel, once the two refracted rays are moving parallel, automatically they are going to form image at what? Infinity. This is a nice drawing. Now look at the board. The images are real. We're looking at f1 now. True or false? So this is at f1 proper. At f1. Guess what is this? Guess what? We have done beyond 2f2. We have done at 2f2. We have done beyond between this and this. So this is case 4, right? Case 4. So this is at f1. F1. Good. So in front of the image is real, and what? Is real because of the line is what? Is active, isn't it? Then image is what?
Is highly magnified.
God bless you, Mama. Is highly magnified. Image at infinity is what? Always highly magnified, because it's at infinity. Like, it can be as big as you can think of. Am I communicating? Once there is no barrier that will hold it, they will continue moving. Are you with me?
I am.
Good. So the image is highly magnified. The last but not the least, where is it from? Image is formed at infinity. Are you with me? So once the two refracted rays are parallel, then automatically the image will be formed at what? Infinity. This is very important. But if they become divergent, the image will go to the back and forth, isn't it? Just like we saw in what? In concave mirror, isn't it?
Yes, sir.
Good. So where are we going to now?
Between f1
And the optical center, isn't it? Can I move ahead? Move on this side. Are you understand what I'm doing? So I can move, right? Good. So here, if you don't understand, you can actually go and watch the video later, isn't it? So I am moving from, okay, this is case 5, isn't it? Case 5. Case 5. Any question? Any question? Michael. Now, we are almost close to the mirror. The lens, isn't it? So, what are we going to do? Where are we going to form? How are you going to form? You guys, you still take. When I become serious now, you understand it very much more better. Be laughing. So, where are we going to use? Rule 2.
Yeah.
So, if this guy move here, you say you're going to move like this.
Yes.
Okay, let's see. Rule 2.
Yes.
I'm going to use this one.
Yeah.
Good. This my line is not the way it should. From what I'm saying, when I go to this side, it's not the way it should, but it's try. Then let me just do you see it? They are not parallel. They are not parallel. Do it in your book. I asked you to do it. Even me that using pen, I've already known that when I drew it, act as though, if even though here is kind of bent a bit, if you continue moving this guy like this, even straight like this, you will find out that once this one is coming down, it will not be moving with the same, it's not giving the same distance between the first one. No, it will be doing like this. Am I communicating?
Yeah.
So that's the same thing that happened on our last positioning when we were looking at concave mirror, which is converging mirror, right? It's happening on what? On the last case when we are now looking at what? Converging lens, which is convex lens. Am I communicating? So what do you think that will happen? Since this guy actually has already become divergent, this divergence, right? Divergence. So it has to do with image formation. Okay. Image forming backward. Am I communicating? Isn't it?
Yeah.
So since they are diverging, what would they do? They will become virtual. Isn't it? In fact, I shouldn't be, let me just go straight. Divergence here, I should be having what? Virtual. Isn't it? So once diverging, I should be having virtual images. So here, they will come here and meet. Isn't it?
Yes.
This one. I'm trying to, get it at least a little bit. Are you with me? So, image here is what? Virtual and what? Erect. Are you with me? Virtual and what? Erect. Virtual. We'll go with erect. I'll confirm from you. Are you done drawing?
Yeah.
Okay, so virtual and the upright or erect. Then 2, from here, highly magnified, is it? Or just magnified, I think. Just magnified is enough. Let me see. When it's highly magnified and magnified are not the same. For, is that it?
Yes.
You're not from the image at the back now.
This one is just going like this.
Yes, now, and I explain how you form image once it's diverging. Once it's diverging, you to go come to the back. See what I did here now.
Okay.
So use that your ruler and trace it for me, like be a straight. Just keep it straight like this. Keep it straight like this. Then, move it. Then
Meaning that it should form behind the mirror.
yes, now
That be the lens.
yes, that's what I'm saying. But my own is I want to know whether it's highly magnified or just magnified. So when it's magnified, you will see maybe the size of the object might just be little above the size of the image might just be little above the size of the object. Am I communicating? But once the size of the image has doubled the size of the object, that is highly magnified. That is high magnification. Am I communicating? I get to my point. So I want to see. For my own, is almost highly magnified. Let me see. Measure now. So this is highly magnified.
Yeah.
Sorry. Okay.
It's 1.5.
This is almost 3 or 3. So highly magnified, right? So highly magnified. Am I communicating? And this is used, or this serves as a magnifying glass. This serves as what?
Magnifying.
All the magnifying lens or magnifying glass is made up of what? Convex or converging what? Lens.
Like microscope.
Not just microscope, I mean that hand one is much more, better. Microscope can be tuned of different magnification. They can tune it to ×2, ×4, as case may be, right? Yeah, for microscope. But this one, I mean, they are just there. The hand magnifying glass is on a hand magnifying lens or something. Okay, so this is the reason why they are upright. You'll be viewing the thing. You have your book, your write-ups, all right, isn't it? Then use magnifying lens on it. It will magnify it. It will not turn your write-up or your drawing to be upside down. No, it will just be the same as how it was being written, or how you have written your write-ups. Am I communicating? So one of the applications of a convex or converging lens is that it is used as magnifying lens or magnifying glass. Are you with me? So where is it formed? The image is formed where? Image is formed
behind the lens.
Behind the lens. Are you with me? With this, we have come to the end of what? What do you call it? Convex lens or converging what? Lens. Am I communicating? So nothing else. Nothing else. So when on your own leisure time, you need to practice all this positioning and get it acquainted with you. Okay? Am I communicating?
Yes, sir.
And when you look at this, hope you can see that the image also formed behind the object. The image is formed behind the object from the diagram. So in case they ask you in exam, it's formed behind the object. All right?
Yeah.
Good. So we are going to be looking at diverging. All right? We'll be looking at what? Diverging lens. Are you with me? Yeah. Diverging lens.